All right, let's dive right into this explainer and explore how NASA is completely transforming the chaotic and honestly often stigmatized world of UFO sightings into a rigorous, data driven scientific investigation. For decades, reports of strange objects in the sky have captured our collective imagination. But let's be real, they've also been clouded by wild speculation and a severe lack of hard facts. Well, things are finally changing. The exact same agency that put humans on the moon and drove rovers around on Mars has released a groundbreaking independent study team report on how to actually investigate these occurrences properly. So, what really happens when the world's premier space agency turns its focus to our planet's greatest mystery? Basically, we're looking at the sky as a literal crime scene, and NASA is acting as the ultimate detective to uncover the truth behind unidentified phenomena. They're bringing their absolute world-leading expertise in Earth observation, data curation, and advanced sensor technology to team up with the Department of Defense's AARO, the All-Domain Anomaly Resolution Office. It's a massive, whole-of-government approach, and NASA is stepping up to provide the exact kind of scientific rigor we've been desperately missing. There's a great quote from Thomas Jefferson that says, "1,000 phenomena present themselves daily which we cannot explain. Their verity needs proofs proportioned to their difficulty." That perfectly hits the nail on the head for our core mantra today. Extraordinary claims require extraordinary, completely reproducible evidence. Whether we're tossing around the possibility of extraterrestrial life or the cryptoterrestrial hypothesis, the idea of a concealed earthly explanation, we always have to remember that in science, extraterrestrial origins must be the hypothesis of last resort. We only go there after we have definitively, undeniably ruled out every single conventional explanation. And look, history shows us time and time again that today's wild anomalies often become tomorrow's basic science, as long as we apply the right tools. Take atmospheric red sprites, for example. For over a century, people reported seeing these glittering orange-red flashes high up above thunderstorms. For the longest time, they were just stories. No one believed them. Now, we know them as atmospheric red sprites, completely explained by modern science. It's exactly like Jocelyn Bell Burnell's discovery of pulsars back in the 1960s. What initially looked like some sort of artificial ticking clock turned out to be a rapidly rotating neutron star. The unknown becomes known through systematic data collection. Okay, Section 1, the UAP Enigma, redefining the unknown. Let's look at how we even begin to categorize what we're looking for. So, here's a real game changer, the shift in terminology. We are no longer using the term UFO or even unidentified aerial phenomena. The A now officially stands for anomalous. And guys, this is a massive paradigm shift because it totally broadens our scientific net. It acknowledges that these phenomena aren't just limited to flying around in our atmosphere, they can happen down in the oceans and way out in space too. We are looking across all domains. Moving on to Section 2, the data deficit. Why eyewitnesses just aren't enough. Because the biggest hurdle in this detective story isn't a lack of sightings. The real problem is a massive deficit of usable, high-quality data. Now, don't get me wrong, eyewitness reports from highly trained military aviators are incredibly fascinating and undeniably compelling. But ultimately, they're non-reproducible. Science requires something far more rigorous. We need properly calibrated instruments that record critical metadata. I'm talking about the exact time, the precise location, the weather conditions, and crucially, the specific noise characteristics of the sensor itself. Without that metadata, you literally can't not make a definitive scientific conclusion. This comparison right here is absolutely crucial. On the left, you see footage from an MQ-9 drone in South Asia, showing an object with this bizarre atmospheric wake. Well, through rigorous analysis, ARO determined this was actually just a commercial aircraft, and that weird wake, it was a known sensor artifact caused by video compression cavitation. But then compare that to the right side, a genuinely unidentified silver orb-like object filmed over the Middle East. Because of limited data, it remains totally unexplained to this day. This perfectly proves why separating mere camera artifacts from actual anomalies is vital. All right, Section 3. NASA's observational arsenal, turning eyes to Earth. To solve this mystery, NASA is pulling out all the stops. Let's look at NASA's actual toolkit. It is incredibly heavy-duty. We have Earth-observing satellites like Terra and Aqua. We've got upcoming missions like NISAR utilizing synthetic aperture radar. And NISAR is incredible because its radar can actually validate physical constraints, meaning it can track the Doppler signatures of anomalous high-G maneuvers or rapid accelerations. Plus, NASA is leveraging the U.S. commercial remote sensing industry, giving us satellite networks with sub-meter spatial resolution. Throw in the VUSC Rubin Observatory scanning the night sky and the 160 weather radars of the NextRad network to filter out everyday airborne clutter, and you've got a seriously powerful setup. And it's not just about spotting the objects directly. Earth-observing tools can capture stunning natural phenomena, like these von Karman vortices forming in clouds. Now, sure, NASA's satellites typically lack the spatial resolution to zoom in on a tiny UAP that's only a few meters wide, but they are still amazingly useful. Even if a satellite can't see the UAP, it can retroactively probe the exact atmospheric, terrestrial, and oceanic conditions that were present the exact moment a UAP was spotted by a pilot. This lets us finally ask, are certain environmental factors associated with these sightings?
Because at the end of the day, data is the language of science. Whenever we venture into the total unknown, we have to remember that data is the only language that can impartially separate fact from fiction. Science is a process that reveals reality. It doesn't sculpt reality to fit what we just wish it to be.
Which brings us to Section 4, AI, crowdsourcing, and pilots, the human-machine team. So we have all these amazing satellites and radars, but how on earth do we process that mountain of information to find the proverbial needle in the haystack? Well, AI and machine learning are our best friends here. They're essential for spotting rare occurrences in massive data sets. But here's the trick. You can't just tell an AI to go find a UAP. First, you have to establish a rigorous baseline of normal events. You have to train the AI on well-curated, perfectly calibrated data sets so it fully understands the background model before it can ever detect a true deviation. Think about it like this. We literally have to define what normal is using known objects. We know the exact range of velocities and accelerations that conventional objects, like weather balloons, drones, and state-of-the-art aircraft, can achieve. By calibrating our sensors to perfectly recognize these everyday prosaic objects, as well as natural occurrences like solar glint, any true deviation becomes glaringly obvious. When an object moves at a verified anomalous speed, the AI is going to catch it immediately. Now get this number, 100,000. That staggering figure is the amount of safety reports the Aviation Safety Reporting System, or ASRS, receives every single year. NASA administers this confidential, non-punitive system for the FAA, and it's used heavily by pilots and air traffic controllers. While it obviously wasn't initially designed for UAP collection, it represents a massive, largely untapped gold mine of commercial pilot UAP data that could be fully integrated into this whole-of-government effort.
But here's the catch. To actually get that data, we have to smash a major roadblock, the stigma. Right now, the stigma surrounding UAPs almost certainly leads to massive data attrition. Pilots see things, but they don't report them because they fear ridicule or career damage. Crucially, NASA stepping in with open, transparent involvement helps destroy that stigma. Applying the scientific method openly in the public eye encourages more pilots and everyday citizens to step forward without fear. And that leads us to our final section, Section 5, the path forward. A systematic search. Let's see how this all comes together.
So, how is NASA laying down a systematic blueprint for discovery? Well, right now in the present, the goal is curating existing data and implementing incredibly strong calibration standards across all agencies. In the near future, the panel recommends boosting data collection through modern crowdsourcing. Think open-source smartphone apps that gather not just photos from citizens worldwide, but all the accompanying smartphone sensor metadata at the exact same time. And in the long term, the ultimate vision is to integrate real-time machine learning analysis directly into future generations of air traffic management systems.
Bringing this level of scientific rigor is exactly what this topic has always needed. Now, I want to be super clear here. The report explicitly emphasizes that there is currently no conclusive evidence of extraterrestrial origins for UAPs. None. But a true scientific mindset means remaining completely open to whatever the curated, calibrated data ultimately reveals, whether that leads to discovering new atmospheric physics, new aerospace technologies, or honestly, something else entirely.
The tools are finally in place. The stigma is fading away, allowing observers to actually speak up. And the scientific method is in full motion. We're literally moving from anecdotes to algorithms, from campfire stories to hard, reproducible data. All of this leaves us with one ultimate, thrilling question. When the noise is finally filtered out and the data truly speaks, what is it going to reveal about our skies?